Hey everyone, welcome to the Unhandled Exception podcast. I'm Dan Clark and this is episode number 40. Getting closer to 50 episodes, we'll definitely have to have a think of a good celebration for the 50th episode. So if anyone has any ideas, do please let me know. Today's episode though is about messaging in Azure, and we're going to try and demystify the various messaging options there are in Azure, as it can be quite confusing to know which service to reach for the different use cases. And with me here today to help me out on that front is Sean Feldman, who is a consulting solutions architect and an Azure MVP. So welcome to the show, Sean.
Thank you, Dan.
So for the listeners, could you give yourself a quick introduction and tell us a bit about what you do?
Absolutely. So my name is Sean Feldman. I'm from Calgary, Alberta, which is in Canada, Western Canada. Solution architect, developer, whatnot. A short bio, I usually say, head in the cloud, hands on the keyboard kind of developer. Been doing various things throughout my professional career. Started as a web developer, like many of us, then drifted more towards backend development and more of distributed systems and messaging. Found quite a lot of interest in messaging in general, specifically Azure, and one of my favorites, which became Azure Service Bus. So that's me in a nutshell.
I remember not so long ago you did the .NET Oxford talk where it was called a deep dive into Azure Service Bus, but that's probably an understatement. So I will definitely include, that was an amazing talk. So I'll definitely include a link to that in the show notes because that really goes like very deep into Azure Service Bus. I think it was about 3 hours long. It was basically a user group talk stroke Pluralsight course. So that was amazing.
Yeah, it's been presented a few times, and to be fair, probably that presentation doesn't do justice to the service because it's quite vast. Even though it pretends to be very simple, there you go, send a message, receive a message in a couple of lines of code. But underneath, there's a giant pile of features and things to know.
Well, we can definitely get into that. But first, I just want to do this episode's listener mention. And this one goes to Carl Sargunar, who tweeted out, another cracking episode of the Unhandled Exception podcast with Clifford Agius. Planes, Maui, checklists, productivity, IoT, prosthetic hands. Great listen. So thank you, Carl, for that. And if you want to get mentioned on the show, just send a tweet using hashtag unhandledexception. All feedback is greatly appreciated. And I'm Dracan on Twitter, which is DRACAN. And a quick reminder that this podcast is sponsored by my company, Everstack, providing software development and consultation services. For more information, visit everstack.com. So messaging. So I guess before we start talking about messaging services in Azure itself, it's probably worth just actually talking a bit about why we would do messaging in the first place. Why do we want to do messaging?
It's a very good question to ask early in the beginning, because traditionally, at least back in the days when I was studying computer science, there was no emphasis on how to build systems, right? It's more around how to structure your code, algorithms, and whatnot. With that kind of knowledge, you go into the wild and, as always, learn on the job through the mistakes and whatnot, and very quickly realizing that systems cannot be online 24/7, and subsystems cannot talk to each other directly all the time and be available. That scaling up or increasing your hardware size or service capacity, if you wish, is also not something sustainable. I mean, nowadays it's a credit card driven development. Back in the days, it was order the server, to run the VMs, allocate the VMs and whatnot. So one of the biggest problems that I started encountering is the fact that, the code was okay, but the system was becoming brutal in production because there were so many interdependencies, and, one domino was failing and the whole thing was basically going down. So I was looking for a better option, like anyone else in software development, right? There's got to be a better way. And messaging showed up. And back in the day, when I was looking specifically within .NET ecosystem, it was Service Bus that attracted my attention. Back in the day with MSMQ support, right? Something that was quite of a revelation back then to me. So this is why messaging, right? It basically enabled me to build my solutions or systems in a more reliable matter. I'll put it this way.
And I suppose we can dig more when we talk about the different types of messaging, because I know we're going to talk about event streaming versus pub sub and that kind of thing a bit later. So I guess once we start talking about that, we can actually uncover why it's more reliable.
That's true. And maybe I should clarify about reliability, because the types of software systems that I was building were usually transactional. So a single, well, now we're going to call it message, but a single interaction, I'll put it this way, within the system mattered a lot. Be it an HTTP request, as a result of a user posting some data on a web application, or a call to an API to submit that data, it mattered. And you're absolutely right. Nowadays, when we're talking about messaging, it's a bit more vast, because we have telemetry and we have transactional messaging and whatnot. So yeah, absolutely.
Awesome. So I'm kind of like wondering about the order we do this in, and we can talk about pub sub versus event sourcing and that kind of thing and these different types. But we're also going to talk about the different messaging options in Azure that we've got, like the different services. And I'm kind of wondering whether it's worth to actually just differentiate between what pub sub is or what event streaming is before we start delving into the actual Azure related options. Is it worth doing it in that order?
Yeah. Whenever I talk about messaging, I tend to differentiate between different types in what I consider it to be a very naive approach, but it works for me. And maybe it will work for our listeners as well. The first type that I'm usually referring to is basic queuing or simple queuing, right? So I have 2 points, point A and point B, that are trying to communicate to each other. And, point A is trying to send to point B a message, which is like a work item, let's say, or instruction or whatever it is. So point A knows about the destination B and it, sends the work item. Usually that is expressed as a queue. So each of the endpoints, I'm not going to call them points, I'm going to call them endpoints, has an address or a queue, right? And that is used to basically send a message. Very similar to traditional snail mail, if you wish, right? With mailbox and a letter that we're sending to each other. Which is not surprising that a lot of messaging systems represent the message as a letter, even though we're sending emails these days. So that's the first type, very simple type. The more advanced type is probably something that I call myself messaging as opposed to queuing, a little bit of a step up. Sometimes it's also called enterprise messaging, when you have, in addition to the queues and direct message sending, a pub sub or publish and subscribe concept. And this one is a bit different because, as opposed to simple queuing, instead of knowing the destination of the message where it has to go, the destination endpoint, we don't know about the receivers. And what we do is we broadcast a message, similar to, FM radio or AM radio, where someone is broadcasting and others are tuning in, but the broadcaster doesn't necessarily know about who's listening in. Similar to a podcast, I guess, these days. So I don't have to use the radio analogy anymore. The value there is that because the destination is unknown and practically doesn't really matter what's the destination, the broadcaster or the publisher is free from worrying about the subscribers and making sure that the message reaches the destination, right? It's part of the agreement, part of the pattern. It also scales kind of nicely because you don't have to know about all the subscribers up front. Therefore, you just publish and don't worry as a publisher, and you don't have to worry about the receivers. They can tune in, they can tune out. It's kind of convenient. It's also very natural patterned for event-driven systems, right? When someone needs to respond to the events. And if we, talking about nowadays about cloud providers, AWS or Azure, Functions and Lambda is a good example, right? When something happens and we want to respond to whatever is happening, we kind of responding to an event that took place. There's a third category, which is event streaming that you mentioned earlier. This is more associated with sort of telemetry because in this case, we're still receiving messages, right? But we're receiving a huge stream of messages, kind of drinking from a fire hose. And I think one important differentiation between that and something like PubSub is that we don't care about individual message as much as we care about transactional messaging when we use transactional messaging with queues and PubSub, because a single message does not make as much impact as the whole stream, right? And therefore, the name stream processing, or at least this is how I explain, that in order to derive something meaningful, you have to process a stream of messages as opposed to just a single message, right? And if I would provide an example, think of a thermostat, right, in greenhouse that receives readings of the temperature every 30 seconds, for example. Maybe that's an exaggeration, but we'll go with that. If I lose a single reading, nothing's going to happen, right? Because the average temperature or the pattern is derived from multiple messages over a longer period of time. So that's another third big category. Obviously, there's some other, I would say, subcategories within these three major ones. And for example, in Azure, there's some specialization. For example, messaging for IoT devices, right? Or messaging through firewalls, specialized service and whatnot. For PubSub, a special message specifically for PubSub, right? They all have their place. And I think in the modern days, it's not one to rule them all. It's more like use what's appropriate for the problem that you're solving.
With the PubSub pattern, that is definitely one thing I really like about the publisher doesn't need to know or care what's subscribing to it. And I kind of think of this as quite often I would try and have the publisher publishing business events, which might be an application-wide thing. For example, I'm trying to think that an order has been created, for example, in an e-commerce app. And that code doesn't need to know or care whether something else is picking up that event and sending an email, an order confirmation email, because they're separate responsibilities. And I really just like in the event-driven kind of architectures where you can have the entire system and everything's just publishing business events, which whatever can subscribe to, especially when we start talking about Azure Service Bus and topics and subscriptions and things. That's where I found Azure Service Bus becomes really useful. And I know you said Azure Service Bus is very deep. I've kind of only used it at a high level with the just standard topics and services, but that's kind of why I default to Azure Service Bus.
Azure Service Bus is definitely an interesting one. I mean, it's called Enterprise Service Bus for a reason, because it's like a Swiss Army knife. The PubSub aspect is definitely a powerful one, because whenever you build, conventional systems that are state-based and respond to the events in order to do some database modifications, or you're going into something very different, a ledger-based, like event sourcing, which is also based on the events, right? So definitely can utilize a service such as Azure Service Bus in multiple ways.
One thing I quite like with the Azure Service Bus topics and queues, and this is one reason I kind of default to Azure Service Bus as opposed to something else like Azure Storage Queues, which I'm sure we'll talk about in a bit as well, is I like the fact that even when it's in production, if I need to, I don't say man in the middle, but if I want to look at the messages going through because I need to investigate something, I can just load up the Azure Service Bus Explorer tool, right click, add a temporary subscription to a topic, and then I can then look at that. I'm not competing with the production consumer.
Right. You're duplicating the message for your monitoring or exploratory needs, as opposed to stealing the message from the system that actually is supposed to consume it.
Exactly. That's one problem I find with queues. You can't just peek the message because you're competing with the production stuff. So I don't know how you would debug that, to be honest.
That's a good question. I think the intention behind the services, we always need to look at the historical development, right? I mean, Azure Storage Queues is one of the oldest services as part of the storage group services. So is Azure Service Bus, but they were developed for a very different reason. The storage queues really started as a simple queue for work items, decoupling between services, cloud services back in the day, who remembers, or probably can look it up as one of the original paths on Azure services. And the idea was to, package work item, ship it to the destination without the source and the destination to be online at the same time, and also allow obviously competing consumer pattern. So the objective was more to enable that pattern, not necessarily to decouple between the sender and receiver, which is what Azure Service Bus Pub Sub or topics and subscriptions are achieving. I probably, and again, this is probably going to be a guess on my part, is that as with any queuing system, the objective was to introduce a queue in between and not so much, the operational concerns such as how do I preview the message or how do I inspect it or how do I replicate the message. Usually in the queuing system, you would have to build something custom right out of the box. And this is probably a note that is worth making, that one of the reasons why we have so many messaging services these days is because the teams, and Azure messaging team and specifically, they are monitoring over the time utilization of their services and the patterns. And that serves as a good, not excuse, but probably a good reason to either split services or start new services. One of those examples would be Event Grid, an Azure service that was spawned off the idea of Azure Service Bus Pub Sub, right? But Event Grid is solely designed for Pub Sub, for the cloud scale and whatnot. So again, these services and the history behind them also drives certain limitations or constraints, right? What you can and cannot do. So yeah, you're absolutely right. For example, with Azure Service Bus, looking at the messages that are published is quite easy. You can, as you mentioned, create a new subscription on the fly and start listening to those messages or copies of those messages. Where with Azure Storage Queues, that would be literally impossible.
Unless you wanted to lose messages in production.
Yeah. That is true.
You don't want to do that.
That is true. There's also other limitations. Again, Azure Storage Queues being a very, very simple service. Even if you would be looking at the messages, you would be only constrained to a certain number. I don't remember exactly. I think it's 36 or something like that, which means that even if you want to pick more than, that number, you won't be just able to do so. And when I say pick, I mean pulling message from a queue without necessarily removing, just to preview the contents of the message, right? When with Azure Service Bus, the team has seen the pattern and it was somewhat more evolved to allow you to pick as many messages as you want or pick by a certain numerical ID and whatnot.
From what we're saying here, it sounds like we're saying, you should definitely use Azure Service Bus and not Azure Storage Queues. However, if we look at the cost, one thing about Azure Storage in general is it's very, very, very cheap, which I know that in Azure Service Bus, especially if you need the premium tier with VNet integration, so it can be private or private link, then that can get very expensive. So I guess it's just pros and cons and just knowing what you need, really.
Yeah, and I think the pricing calculator should be also coupled with the needs, right, of each customer and each client. Because not everyone necessarily needs the premium Azure Service Bus. Not everyone necessarily needs Azure Service Bus to begin with. Some systems are just fine with Azure Storage Queues, for example. It really depends on what we're building. For example, if I'm running a significant size system in production, I would probably be more comfortable at night sleeping knowing that messages going through a premium tier as opposed to a standard tier. Not that standard cannot do the job. It really depends on the requirements. The cost is a good point because right now Azure Storage Queues compared to Azure Service Bus is definitely much cheaper. And there's a huge gap between Azure Service Bus standard and the premium, even with a single messaging unit, which is unit of scale for the premium tier. And I hope to see in somewhat near future something in between. Ideally, pay-to-play kind of model where you can select the features that you want from the premium and pay for those, as opposed to pay for the entire premium and just leveraging certain features from all of those. Ideally.
Yeah, that'd be nice. I guess while we're on the topic of cost, and this is something a couple of years ago, I think it was, that you helped me out on Twitter, where I was querying about the base cost of the standard tier of Azure Service Bus, if you've got multiple ones in the same subscription. And I think the pricing details it doesn't stand out that this is the case, but then you got back in touch saying that apparently within the same Azure subscription, multiple instances of Azure Service Bus, I think they're called namespaces, you only pay that base cost once, which is actually super useful if you've got a team of developers that want to dev Azure Service Bus instance each. You're not paying £10, £15 or I think it's $10, whatever it is, that is in pounds. You're not paying that per developer per instance. So I think that's a really useful thing for people to know. So yes, thank you for that. It's been really useful.
Yeah, it's actually an important thing to understand that one-time fee or monthly fee, right? I should say one time, is for the subscription on a subscription level, and the number of namespaces that can be created it probably exceeds the number of developers involved on the project. So it's that single fee, and then the number of namespaces as many as you want, and you just pay for the transactions based on the number of messages that are sent out. This is an interesting one because there is a hot topic of local development or team development and whatnot. Azure Service Bus does not offer an emulator for good or for bad. And a lot of developers, when they start developing with Azure Service Bus, the natural tendency is to search for that emulator. When they start reading the documentation on the price and get confused, because if you have, for example, a team of 20 developers, does that mean that you pay that $10 or pounds 20 times or not? So the answer is you pay only once. And then whatever the number of messages that you send and namespaces can be provisioned at any quantity that you want. So yeah, it's a definitely good piece of information to know about.
Yeah, that'd be so nice if there was just a local emulator, something you can spin up in Docker. So you've got all your Docker databases. I quite often local development use RabbitMQ. I'm sure we can talk a bit about abstraction libraries like mass transit and that kind of thing. And you've already mentioned Service Bus, but at the moment I kind of use RabbitMQ locally, but then Azure Service Bus in production. And it's a shame I can't just use Azure Service Bus for all of them and just in Docker locally spin up Azure Service Bus, an emulator.
It's true. For a developer from a local development point of view, emulator would be definitely helpful. I tend to have a slightly different perspective on the topic. Many will disagree with me. I also tend to have somewhat empathy to the messaging teams or any development teams because certain services either were not designed to run as an emulator or just the plain fact that emulators are constantly catching up with the real product if the real product is not packaged within the emulator itself, right? So for example, storage emulator, Cosmos DB emulators, all those. If you're just using, the basic functionality, just common to many, then probably you'll be fine. The moment you start deviating into more advanced features, that line is becoming blurry because do you support it for just a few developers and provide that functionality in the emulator? Or do you spend that time on actually growing and developing the product rather than spending it on the emulator, right? I think down the road when it comes specifically to ASB, there were a few options that were raised kind of interesting because it is AMQP behind the curtains. Potentially that emulator could be something that is not necessarily the cloud architected solution, but something else, and allow local development for those that have to be in the disconnected mode down the road.
So just going back to Event Grid, which you mentioned, am I right that when you go to the portal and if you go to pretty much most services on the blade where you've got the menu options and you've got one that says events, that's Event Grid? So it's very tightly integrated into Azure itself.
It's quite tightly integrated. That's true. And the nice thing about Event Grid is the idea, maybe we should kind of expand on that a little bit, is that the pub sub with something such as Service Bus, Azure Service Bus service, is constrained to the namespace. And in order to connect to the namespace, you have to have the credentials, right? Which is okay within the boundaries of an enterprise or the boundaries that you can control. But once you want to have subscribers outside of your organization or even outside of your system, that becomes a little bit of a security challenge, right? Not to mention the fact that it probably won't scale that great because there are always, such as for any service, certain constraints on number of connections that can be opened and maintained at any point in time. So that is why the event grid as a service was created, to allow PubSub outside of that concept of namespace, right? And be in the times of internet solutions and whatnot, allow you massive scale of notifications of the PubSub publishing and subscribing to the messages, either within the organization or outside of the organization. And because it's no longer constrained to the namespace, subscribers could be, whatever you want, anything that can basically process HTTP webhook behind the scenes. The nice side of Event Grid is that it also allows a better event passing around, I would say. So for example, if I have blobs, storage blobs that are changing, right? I could subscribe to the blob change directly on the storage account, or I could do that through Event Grid, right? And Event Grid would be somewhat more accurate when the number of storage blob events is going up, because it's no longer based on simple file system notifications or whatever is implemented for the simple scenario. And if I'm not mistaken, even if you go and read, for example, storage blob documentation, they do recommend to switch to Event Grid once the number of events is becoming high. And that's partially to the fact that Event Grid is really scalable and designed to handle massive amount of notifications or messages with large number of subscribers, right? Allowing it to perform no matter how many subscribers or events you're going to have.
In that, you use the term namespace quite a bit then, and I know that's referring to Azure Service Bus, but it feels like maybe for listeners that haven't used Azure Service Bus, that term might be a bit confusing. And am I right that for all intents and purposes, you could say a namespace is pretty much, as far as users that are used to creating resources in Azure, it's an instance of Azure Service Bus?
That would be a very accurate description. Yes. Yeah.
So it's basically an Azure Service Bus resource. For the listeners that were unsure what that term meant, so going back to what you were saying about Event Grid, are we saying that where normally for using Azure Service Bus, a publisher will be talking to that instance of Azure Service Bus, a subscriber will be subscribing to that instance of Azure Service Bus, where for Event Grid, it's more an integral part of Azure's resources like storage and like all these other parts. So it's more part of the Azure mesh, I guess. Is that the right way of putting it?
In a way, yes. And not only that, it doesn't have to be Azure resource, because Event Grid can reach outside of Azure infrastructure, right? So your subscribers, for example, could be third-party webhooks, right? Or webhook processing services. You can also have a third-party publishers on Event Grid, which have nothing to do with Azure. I don't remember quite the names, but I believe it was SendGrid, for example, is one of them. And the beauty of Event Grid, in my opinion, is that you also don't have to worry about the resources, because, for example, if subscriber is an external party altogether, you just invoke their system, similar to invoking a webhook. The difference, I guess, is that the responsibility of handling those messages is now falling on that third party, obviously, right? And it's even further decoupling, because with Azure Service Bus, like we said, as Azure Service Bus is represented, the resource is represented by the namespace. A namespace has a capacity. And for example, if we publish messages on a namespace and there's no subscribers, those messages are piling up, overfilling our subscription, right? Similar to a regular mailbox that eventually explodes and we can no longer put any messages. This is not the case with Event Grid, because the responsibility of emptying that mailbox or receiving the messages is on the receiver, if it's external system. Now, it doesn't mean that it's unreliable, because the moment people hear, oh, it's a webhook, I can invoke it. What happens if that third party is not online? There are retries. There's also the concept of dead lettering, or what to do with the message when the receiving party is not available. So it's kind of thought through to make sure that, messages are not lost with Event Grid.
Cool. You actually preempted my next question then, because whilst I've used Azure Service Bus a lot. I've not really used Event Grid. And when reading about the differences, one thing I read quite a lot is where normal pub sub is kind of push pull, whether they push for the publisher, pull for the subscriber. Then Event Grid is push push. So the message is being pushed to the subscriber. So, and as you said, like a webhook, like it's an outgoing push request. So yeah, so my next question was going to be like, how does it handle reliability there? But if it's got stuff like dead lettering and retry logic, then that's quite cool.
To expand a little bit on that one, the retry logic is very nice because out of the box, there is, I believe, 24-hour retry period when it goes from a more frequent retry to a more backed off retry. And that retry policy is configurable. So for example, if you don't want to bother with more than, just a couple of hours or just a few retries, you can define that. And that lettering is the last time that I was dealing with Event Grid was basically ability to store the payload, the message, for example, in storage account. And you can probably make it a bit more sophisticated to serve whatever the needs that the system has and, introduce replaying of the failed messages and whatnot.
So where would you go? I know I mentioned before, like with Event Grid, like you go to the portal and you go to like Azure Storage and you've got a menu item called Events, and that's kind of like in quite a few different Azure resources. So I can go in there to create a subscript. If I was doing click and create, obviously ideally doing infrastructure as code, but if I was doing click and create, I went to a storage account, clicked on events, added the subscription to an event type, like a blob was created or whatever. Because Event Grid is distributed and we've not got this single instance or namespace like you have with Azure Service Bus, where would you go to manage this thing called Event Grid? Is there a dashboard where you can see all the events and get an overview of what's going on?
There's a certain degree of what you can do. I don't recall being able to look at the messages. Perhaps that has changed recently. I'll have to refresh my knowledge. But one of the things that distinguishes Event Grid from Azure Service Bus is that Azure Service Bus is more of a traditional enterprise bus, right? Enterprise messaging, where Event Grid is more of a modern service where you don't necessarily go to review every message or pick those messages, right? There used to be an open source tool created by a fellow, I believe his name is Roman Kiss, that created a viewer for Event Grid back in the days, and maybe it's still around, that technically allows you to see the messages. But one thing that personally I see with Event Grid is being distributor of highly scalable and high load messaging system. The necessity to probably examine a single message would be less important, in my opinion. But again, your mileage may vary. With Service Bus, I think the transactional nature and intimacy of, I'm sending a message or publishing a message, and I know what is going to happen to that message is most likely becoming the more driving force to evaluate and look at those messages, especially when developing and debugging, right, the system. So that's the idea. With Event Grid, I think partially that problem is solved because you publish in events, right? You don't have something that I would call command, which is point to point or endpoint to endpoint. Those events have a schema, which is basically the contract. And all you do is publish the facts of what happened. That's also the nice part about PubSub in general, is that you're talking in somewhat absolute truths, right? Event is what happened. You can't change that. So you can only read it and react to it, as opposed to expectation of doing something when you receive a message, which is endpoint to endpoint.
Yeah, definitely. And that ties into what I was saying before about with event-driven architecture. It's like business events. If something's happened, it has happened. It's modeling real life things that have happened, like an order's being created or whatever it is in that business.
Yeah.
So would I be right in saying that Event Grid probably doesn't replace Azure Service Bus, but they probably would play quite nicely together in some scenarios?
They would. One of the things, for example, with Azure Service Bus is, like you mentioned, you have to poll for the new messages, right? Not every system has to continuously poll. One of the features is with Azure Service Bus and Event Grid is to actually get a notification when there are messages available and no active listeners, which is on the Azure Service Bus namespace, you don't have to continuously poll, and you only can wake up a service or a process to consume the messages when those are available. And that is based on the notification coming from Event Grid, right? So that's the combo that you could leverage.
It does seem very powerful. I do need to play with Event Grid more, because I kind of looked at it, and because I was using Azure Service Bus, I then didn't really need to use it, but I feel like I just need to have a bit of time just playing more with it, so I understand it better for when the time comes that I've got a problem where it would be the ideal solution. So with just thinking about other different services, we've spoken about Azure Service Bus quite a lot. We've spoken about Azure Storage Queues. We've spoken about Event Grid. There's something else named very similar called Event Hubs, and I believe that ties into the event sourcing we were talking about before. Am I right that Event Hubs is pretty much Kafka for Azure?
You are absolutely correct that Event Hubs, similar to Kafka, is dealing with event streams, and it's capable of processing quite a large number of incoming messages. The interesting thing about Event Hubs, and something to keep in mind, is that really Event Hubs is designed for that insanely large ingress, right? That is coming in order to do something later with those messages. So the concern with a service such as Event Hubs is not necessarily to handle a single message, but rather make sure that every single message is captured, right? And the processing is coming later. That is why, unlike Azure Storage Queues or Azure Service Bus, Event Hubs is geared nicely to work with other services to push that data that is coming in, to push those messages into something like a data lake or storage or whatnot for later processing, because as any other event stream, the interest is not really in a single message as much as in the stream as a whole, right? To derive whatever it is, the statistical or over the time insights. One thing that is probably worth mentioning, and this is the theme that we can trace through with all these services, is that Event Hubs historically was part of the Service Bus as well, which is kind of ironic because they both used to have a namespace which would be provisioned under Azure Service Bus. Later, once the messaging team has seen the patterns and the needs, they split the two. And now they're two separate services, which makes more sense.
Am I remembering correctly that when you did that .NET Oxford talk about Azure Service Bus, that you said from an implementation point of view, standard and premium are like completely different implementations behind the scenes?
That's a fun fact, and I believe that was publicly shared. The Azure Service Bus had a basic and a standard tier in the beginning. Then a premium was introduced. And the needs on the premium, customer needs, were, obviously heavier. And the messaging team was, evolving what they were building to the point where I suppose it diverged. And for example, the storage engine behind the scenes is very different. The original standard tier was using SQL Server, if I'm not mistaken, as the backend storage. That's not the case with the premium. You can also trace it through with the implementation differences through things such as partitioning, which is the ability to kind of shard your queue. And partitioning was available on both standard and the premium until the team has found that, partitioning doesn't really help the performance on the premium tier, and it was completely removed. So nowadays, one of the complexities, if you wish, with power comes responsibility and complexity. When you're working with standard and premium, is that on premium, there is no partitioning, where partitioning is still available on the standard. So things to keep in mind.
Quite fascinating how like standard and premium have diverged, but they started the same. And that's what made me think about it. Event hubs as kind of also come from that starting code base or implementation. So it's quite interesting how like they're just reusing like Azure Service Bus for a lot of other stuff and growing it as they learn stuff, I guess, as they learn what the different requirements for different customers are.
Yeah, which I think it's very common to software development and software engineering in general, right? As we build systems and assuming that you stay with that system for a while, you see the change in the needs and potential improvements that can be made. And sometimes trying to keep it, all within the same system is difficult. It's easier to sort of, similar to analogy of open source project, fork, right? And run independently and maybe contribute back later. So I think that this is kind of pattern that makes a lot of sense for these services.
Yeah, definitely. So we've spoken about a few different services. In the messaging space, are there any other services that we should be aware of?
There's another one that is probably worthy of mentioning, IoT Hub. Unlike event hubs, this one is specifically geared for IoT devices, which is interesting on its own. There's also one that serves as old as Azure Service Bus itself and doesn't get a lot of attention, but still, in my opinion, quite cool, which is Azure Relay, which is technically, when I'm trying to describe it in my own terms, is ability to penetrate or connect through the firewalls, right? So basically, think of it as instead of trying to go through that firewall, the two endpoints establish a connection point on a namespace within Azure Relay and basically go through a public channel WebSocket, for example, right? With conventional HTTP ports that can be opened or most likely open. And that basically allows to connect to services that otherwise would be completely shielded. And good luck opening that connectivity. So definitely an interesting one when you have the use case.
So is that hybrid connections?
That used to be called hybrid connections, yes.
Right, okay. I used that a year or so ago. We needed a temporary solution to do exactly what you're talking about, where there was some on-premise resources we need to access from Azure. And at the time, I can't remember why, but maybe it was before private link and that kind of thing, or we just needed it to work quickly, a quick solution just for an interim. And hybrid connections was perfect because we could, as you say, tunnel in, but there wasn't an ingoing connection. The hybrid connection or Azure Relay connection was going outbound from on-premise. So there was no firewall ports being open. So that was quite nice.
Yeah.
With the IoT Hub, I think there's something else as well called the IoT Central. And as far as I understand it, that's kind of more like a SaaS offering where it's like you actually get, rather than having to develop against it, I think you get like a portal and everything. And you can do, I don't know whether it was without code or minimal code.
Well, I don't do a lot of IoT on a day-to-day basis, but the idea there is that you can communicate with the devices and it's not one way. It's bidirectional. So it's kind of nice because not only you can read the status of your devices, but if your devices are capable of receiving, and for example, updates or commands, then you can send those. There's another one that I'm blanking right now. There's IoT Hub and there's another one, Notifications Hub, which used to be quite hot back in the day with all the push notifications, right? And I think that one is quite nicely designed to facilitate push notifications for different mobile systems. Well, nowadays, I guess it would be iOS and Android. Back in the day, it was also capable of Windows push notifications. RIP Windows Phone. So that one is no longer an option.
Yeah, I'm just thinking for the IoT Hub and IoT Central, a couple of episodes ago, Clifford Aegis on talking about, it was talking about Maui. We also had a section talking about IoT because he's quite into IoT. So he spoke a bit about IoT Hub and IoT Central. And I think if I remember correctly, he was saying that the IoT Hub, the events, you'd have to send the events to something else to actually view them and do something with them, where IoT Central, it's an all-in-one solution, I think. But Don't quote me on that. If you've not listened to that episode, go back and listen to it because it was an awesome episode.
Always go to the current documentation. That's the rule.
Yes, that's a good one as well. But listen to the episode too. So given in your .NET Oxford talk, which was a really deep dive into Azure Service Bus, it's probably worth talking a bit more about that. And we've spoken about topics and subscriptions and we've mentioned queues, but is it worth just digging in a bit and discussing the difference and how the relationship between topics and subscriptions actually work in Azure Service Bus?
Absolutely. So queues and topics with subscriptions are constructs in Azure Service Bus namespace, also known as entities. Queues are similar to mailboxes designed to hold on to the messages, like a storage place. Topics are designed to distribute messages. So they don't hold on to the messages. They just pass those messages on to the subscriptions of the consumers, competing consumers also. And the truth is that queues and subscriptions are pretty much almost the same thing. In the end, it's basically a mailbox, a queue. The difference in name is because a queue doesn't have any filters. It just gets all the messages that it's supposed to receive, whereas subscription has a filtering capability, which allows it to evaluate every message that is sent to the topic under which subscription is found and decide whether it's going to get a copy of that message or not. And the filtering is usually done on the metadata of the message or headers, also known as application properties, system properties. So for example, if I have a header that is indicating the importance of the message in terms of priority, I could subscribe only to the high priority messages or low priority messages, or I could say, give me anything that you seek. So that is the biggest difference between queues and topics with subscriptions. Simpler services such as Azure Storage Queues, having only the concept of a queue, that doesn't exist.
Yeah, I guess even if we just take these rules and filters out of the equation and just think about the relationship between topics and subscriptions, the way I think about it is, and the way I try and explain it is, with a queue, it's kind of, we spoke before about competing consumer pattern, where if you've got lots of different subscribers, then only one of them will get that message. So you can scale out, you can distribute the load, but only one of those things will get the message. Where with a topic, an event can come in, and you can have, say, for example, 3 different subscriptions to that topic. And you get the same competing consumer pattern, but for each of the subscriptions. And the way I tend to do it is something publishing to the topic is publishing a business event, like we've discussed before. And I guess it's worth being clear that a subscription is an Azure entity, an Azure construct, not something in your code, where normally you'd make a subscription in code, but that's not what we're talking about here. You'd make a subscription to a subscription, if that makes sense. And I would then have a subscription for each business area that's interested in subscribing to that business event. So one subscription might be send order confirmation emails or whatever you want to call it. One might be process payment gateway, or I don't know, whatever these different things are. It's really hard to explain without drawing a graph, actually. That's how I normally explain it.
I think the example that always worked for me in the past was, how do I insert man in the middle when I have point A talking to point B and no way to intercept it? So for example, when it's an HTTP request, we have a tool like a Fiddler where we can tap into the communication to see what's going on. For example, with Azure Storage Queues, given that it's also an HTTP-based service, we could do something similar, but we would not be easily able to do that if it goes, for example, over HTTPS without decoding it and whatnot. So it imposes a little bit of a challenge. Also, when the message is sent, it's sent. If we were not listening actively at that moment, we would not be able to see the message going through. With Azure Service Bus, what happens is we sort of install a spyware, if you wish, by creating an additional subscription where the criteria for the filtering of the messages is basically catch all, everything, catch all. And that means that whenever messages are published to the topic, we're always guaranteed to have a copy, and we don't have to be online to look at those. So a lot of times what I would do, for example, in my development is I would create a catch-all subscription under the topic, right? And evaluate all of the messages that were sent to the topic. So that's how I usually use that.
Yeah, that makes sense. And I guess you could also, if you had like a subscription, which if you wanted to do some kind of reporting and you wanted to just ship all the events to Azure Data Factory or whatever it is, then you could just add another subscription for that. And that would just offload all those to something else.
Definitely yes, though you always need to be careful what you're wishing for, because the system might be overwhelmed with all the messages, right? And sometimes planning for it is better than just catching everything, just because, again, you have to receive the messages and counts as transactions. If you, for example, if you receive all the messages, but let's say consume only 5% from those messages for reporting, it's kind of wasteful because you're paying for the delivered messages that you have no interest in. So that's where I kind of tend to look at this subscription and say, okay, maybe I better configure on my subscription that filters out what is not important. I think one feature that is definitely worth mentioning is also forwarding or auto forwarding, where one entity can forward message to another entity. And with subscriptions, it's actually quite powerful because now you can start putting that Lego together and build what is known as topologies, right? So you're no longer constrained just to that subscription. You can forward from the subscription to another topic or to another queue. And it's really becoming interesting, especially when you have systems that evolve and you need, redirect messages from one entity to another without necessarily breaking the legacy systems.
Yeah, I remember you demoing that with your .NET Oxford talk, and you had like it doing lots of forwarding. I think, was it 4 or 5 where it was the limit, and then you're asking the audience, do you think this next one's going to fail or succeed? And then
that's correct. Yeah, and it's an interesting one because, for example, anyone who's coming from RabbitMQ is used to the fact that you can have as many hops as you want. With Azure Service Bus, the design is different. It is more protective, and it's trying to shield customers from infinite hopping. So it literally puts a hard stop after 4 hops.
Yeah, that makes sense. So whilst you mentioned RabbitMQ and we're talking about topics and subscriptions, for the listeners that are used to RabbitMQ but haven't used Azure Service Bus, would it be a good comparison to say that where RabbitMQ has got exchanges, then queues, that's a very similar analogy to Azure Service Bus's topics and subscriptions?
It is similar. There is a little bit of a difference, slight difference. The exchanges can behave in a bit more advanced way than topics. With Azure Service Bus, topics are, should I say, somewhat dumb because their whole purpose is just to receive message and forward to the subscriptions. So there is a little bit of a difference. Not to mention the fact that also the underlying implementation is different. Even though both are AMQP, they implement different standard. 0.9, I think, is the RabbitMQ as opposed to 1.0 for Azure Service Bus.
Right, I see. So one of the topics we were going to talk about is abstraction frameworks. So things like mass transit and service bus. So how does that deal with those different versions that you just talked about?
So that's a good question. I've been contributing to on Service Bus on Azure specifically for quite a while. What happens is the problem that these frameworks or tools are solving is introducing a level of abstraction that is transferable from one messaging technology or queuing technology to another. And where the abstraction is not fulfilled by the native technology, the abstraction then is implemented and introduced by the library itself. So for example, obviously both Mass Transit and Service Bus and others leverage the SDK clients that provided out of the box by vendors. And that is used to build around the abstraction. A good example would be for Mass Transit. Mass Transit supports RabbitMQ and Azure Service Bus. A while ago, it used to also support other transports, which were deprecated, and Service Bus has somewhat more of what they call transport, right, for backwards compatibility and support. So for example, if we would look at Azure Storage Queues and Azure Service Bus has pubsub out of the box. storage queues doesn't. So this is where these abstraction libraries, can compensate for the lacking features and implement those. But these abstraction libraries always have to have some baseline that is shared by those different technologies. And if there is no baseline, then it obviously has to be created. For example, nService Bus has a SQL Server transport, which is kind of interesting because, we're schooled not to use database as a queue. But the reality is that there are places where they either cannot introduce a new technology, but they always have something like SQL Server or similar. So nService Bus allows to utilize messaging with all the standard features by using SQL Server transport.
I haven't actually used nService Bus. I have used Mass Transit. And back in episode 31, we actually had Chris Patterson on to talk about Mass Transit because he's the main author. And I like the way with Mass Transit that, well, as I mentioned, it can use RabbitMQ locally in Docker, but in production it's using Azure Service Bus. But I also like the way it just manages and creates the queues, topics, and subscriptions based on convention from your .NET classes, your DTOs, and it just does all that stuff for you out of the box. And I'm sure nService Bus probably does similar.
It's very similar. I think the general pattern that we see these days with these abstraction libraries is that they provide either the out-of-the-box experience when you just run the solution and the infrastructure is messaging infrastructure that is created for you on your behalf, or an alternative where you need to control what is created and how it's deployed, and you remove that F5 experience, right? You provision yourself, usually something like infrastructure as code, Bicep, ARM, Pulumi, whatnot. The interesting fact is that there's not always a possibility for the abstraction libraries to do the job. A good example would be Azure Functions, where it's a little bit of a chicken and egg, because when you deploy a function for Service Bus, it has to be triggered by messages on the queue subscription, which means that that queue or subscription have to be there from the get-go. So you can't really have the abstraction library create that entity. You have to create the entity first and then deploy the function. So, and it also depends on the teams and their preferences, right? There are some teams that really want to control every subscription, every queue, every topic, everything that is created, source control it and whatnot. And there are teams that rather prefer not to do it, with the one caveat that, for example, with PubSub, due to the fact that to the nature of being decoupled and not knowing who's subscribing, if a subscriber is going away, that subscription has to be removed, right? Otherwise, it will stay there forever.
Yes, yeah. I guess also it's because to actually create topics and subscriptions and all this stuff, am I right that in Azure Service Bus, the connection string actually needs the manage permission, which it might be the kind of thing that your ops team really wants to limit who has that permission. I think there's read, write, and manage, is there, when you're setting up the permissions?
Read, write, and manage, that's correct. And with Azure Active Directory, you can go without connection string, but still the permissions not as fine-grained as many probably would wish. It's creating entities definitely requires management rights. Checking for entity existence, for example, is the same story. So yeah, like I said, one of the reasons why I also call it enterprise service bus is because within the enterprise, that's less of a concern probably. But if you run in multiple teams and you want separation and whatnot, it can become a little bit challenging.
I see. Where before, when I asked about how do these abstraction libraries get around the different versions of AMQP, and you said that because it used the client libraries, if we actually then move on from talking about the abstractions, and if you just wanted to use these client libraries directly without using an abstraction, presumably you've got like options in different languages, in like .NET and JavaScript or Java.
So there's been very big development in the SDKs arena. Traditionally, for example, Azure Service Bus SDK was predominantly .NET. Nowadays, it's .NET, Node.js, Java. I think there's also Python and whatnot. Microsoft has upped the game a little bit in terms of supporting the languages. And what's nice about those SDKs is that they are language specific, as opposed to having that is transpiled, from .NET or from HTTP to everything else. There is a GitHub repository for every SDK. What is different nowadays is that Microsoft is grouping SDKs for various services per language. So there is a .NET SDKs repository, there is Node.js, Python, Java. And these SDKs are iterating quite quickly, adding features and addressing bugs and whatnot. So the abstraction libraries usually tend to follow the latest version of the SDKs to bring the features and whatnot into the abstraction and utilize the latest versions.
Nice. Yeah, I do love the way that everything is now on GitHub, so you can just go and look at it and look into the code as well.
Not only that, but also being able to engage in the discussions with the development team, with the SDKs team, right? And in the past, I've participated in a few discussion issues where the team is taking the approach, the messaging team not messaging team, the SDKs team was bringing to a discussion certain aspects that they were not 100% sure, listening to the feedback that customers can provide, or users of the SDK, which is quite powerful. It also kind of nice because the latest generation of the Azure Service Bus SDK, for example, which is a third generation, if you wish, has been polished to the point where it's fairly easy to start with the SDK. And as you progress and your needs are increasing, still feel comfortable about using it with the advanced features and whatnot. It was not the case in the past. So wherever you're using an abstraction or you prefer to roll your own for whatever the reason, you are in a good position nowadays because the SDKs are quite supportive.
That must be so useful for these abstraction libraries like Mass Transit, just being able to see what's going on with these client libraries. Speaking of open source things, there's another tool which we did actually mention before, this Azure Service Bus Explorer. And this is absolutely amazing. Am I right that you've contributed to it as well?
That's true. The tool was created by Paolo Salvatore. He's a Microsoft fellow that has built the tool quite a while ago, actually, which is kind of ironic because until recently, this was probably not the only option, but probably the go-to option whenever you were doing Azure Service Bus-based development. And I was helping a little bit with the tool, as many other community members that were sending PRs and whatnot. I think nowadays the state of the tooling has significantly improved. First of all, there is an option now in the portal to perform some of the basic operations. And what's nice is that just recently Microsoft has announced their commitment to improving that tool. Obviously, it will iterate, it will take some time, but it's really nice that they have it on their radar. There's also quite a few tools that are available now for other platforms, because Service Bus Explorer originally started as a Windows Forms solution. Now there's also options for Mac from other projects. I think there's also one that is cross-platform, which can run on Linux. So definitely more options nowadays than before.
That's very cool. I hadn't actually clicked that Azure Service Bus Explorer was Windows only, so that's a very good point. It's also like your point about the portal improving, because I know I've looked at that in the past, and it's not been a patch on using Azure Service Bus Explorer because it's just very limited. So it's good that Microsoft recognized that and are trying to improve that experience.
Absolutely. There's also some commercial tools that are available, again, really depending on the needs. But like I said, it's much better nowadays than it used to be in the past. And even though Service Bus Explorer is still Windows only and WinForms, I think it's going to be very interesting to see the development of the portal tooling and where the community can potentially take Service Bus Explorer or others, right? Because out of this friendly competition, I believe the best thing will emerge.
Yeah, there's nothing like a bit of competition to actually help things evolve. So all these tools, we will definitely make sure that we include a link to all of these things in the show notes, especially Azure Service Bus Explorer, because it is awesome. If you use Azure Service Bus, definitely check it out. But we are actually quickly running out of time, so shall we do dev picks?
Absolutely. I know we're supposed to pick some library or something that is related to the software, but I would actually want to do one that is hardware more than anything else. Being looking around for a new laptop and being also very picky about what's available, I stumbled upon quite a while ago framework laptops. And that was quite refreshing to see, just because the concept is not novel, but very different from mainstream manufacturers. Specifically, this is a laptop where you can replace absolutely everything, starting from a mouse pad to keyboard to motherboard, battery, screen matrix, you name it. This was quite a nice find.
Yeah, I'm just looking on the website now. So this is frame.work. So that's the website, frame.work. And it does look very cool. I'm kind of, maybe just over a year ago, I switched from laptops to my desktop here. And the one thing I like about desktops is just that you can upgrade stuff and configure it, where this sounds like it's that for laptops, which sounds amazing.
Yeah, I wish that project a lot of luck and back them up by ordering one yesterday.
Oh, nice. You'll have to let me know how it goes.
Absolutely.
I'm just watching the animation of them changing everything and customize everything. That's pretty cool. Again, like as usual, I'll include links to this in the show notes. So my dev tip is actually more of a health tip, but it does relate heavily to us as developers, because we sit down a lot as part of our job. And I'm guessing I'm going to see Sean nodding, because I know a couple of days ago we spoke in depth about backs. But my dev tip is to pay close attention to your posture, because I'm currently having all sorts of back issues at the moment. I know, as I say, we spoke about that the other day. And some of my back issues relate to an old back injury, but some of them probably relate to just plain old bad posture habits. And it's the old, like, I'm fine, my body is quite comfortable while I'm slouching, it won't happen to me until it does, until you get a bit older and it does. And it's not pleasant at all. So my tip is to pay attention to your posture. Those infographics that you see in offices that go around showing good desk posture, they're there for a reason, they're not wrong. And at the moment, I can't currently play football with my kids. I can't go for runs, go to the gym, all things I love doing. Hopefully it's temporary and in a few months I'll be better. But yeah, basically look after your back and spine. They're pretty important.
It's a very good tip.
So before we wrap up, where's the best place for listeners to reach out to you if they have any questions?
Twitter universe. I'm there as Feldman, at Feldman, or just straight email, feldman.sean@gmail.com, and both will show up in the podcast links.
Yes, I'll definitely include that in there. And I will also include links to your amazing .NET Oxford video, which, if the listeners want to go quite deep into Azure Service Bus with obviously video as well as audio, then yeah, definitely check that out. So with that, just a massive thank you for joining us on the podcast. It's been really good having you on.
Thank you, Dan.
You're most welcome. And thank you everyone else for listening. A quick reminder that this podcast is sponsored by Everstack, which is my own company providing software development and consultation services. For more information, visit everstack.com. And if you enjoyed the podcast, please do help me spread the word on social media. I normally use the hashtag unhandledexception, and I can be found on Twitter @Dracan, DRACAN, and my DMs are open. And my blog, danclark.com, has links to all my social stuff too. And as I mentioned before, we'll include links to all the stuff we've covered today in the show notes, which can be found on unhandledexceptionpodcast.com.